Hello, everyone, and welcome back. In our previous lessons, we've learned many of the building blocks of Python programming. We started by learning variables, data types, then explored operators, conditional statements, loops, strings, lists, and sets. Using these concepts, we've written several useful programs. However, you may have noticed that some part of code is repeated over and over again. Today, we're going to solve that problem by learning about functions. Functions are one of the most important concepts in programming. They allow us to write a piece of code once and then reuse it whenever we need. Almost every professional program, from websites and mobile apps to games and even AI systems, makes extensive use of functions. By the end of this lesson, you'll know how to create your own functions, pass information to them, and receive results back, understand the variable scope, and even write simple one-line functions using Lambda expressions. Let's get started. So before we learn what a function is, let's first understand why we need them. Now imagine that every time a player enters a game, I want to display a message that is welcome to the game. Now, do I have to write this each and every single time, welcome to the game, welcome to the game, whenever I want to display the text? We'll be writing exactly the same code a lot of times. Now imagine that we needed to display this welcome message 100 times throughout a large application. Copying and pasting the same code again and again creates several problems. Our program becomes longer to read, it becomes harder as well. If we need to change the message, we must edit every single copy of that print function. It's easier to make mistakes. So instead, wouldn't it be better if we could write this code once and simply reuse it whenever we need? That's exactly what functions allows us to do. A function is a reusable block of code that performs a specific task. Think of a function like a machine. You give the machine some instructions or inputs, the machine performs a task, then it produces an output. For example, a calculator performs calculations, a washing machine washes clothes, a coffee machine makes coffee. Similarly, a Python function performs a programming task. Some examples include displaying a greeting, calculating the area of a rectangle, checking whether a number is even or odd, finding the largest number, or even calculating a group of students' average marks. Instead of writing these instructions every single time, we will place them inside a function. Then we simply call the function whenever we need it. In Python, we create a function using the def keyword. Let's write our very first function. Now, as you can see on the screen, instead of just writing print hello welcome to Python, I've put it inside a function called greet, which I created using the keyword def. Now let's understand every part of this code. The keyword def tells Python that we are creating a new function. Next comes this function's name. In this example, the function is called greet. After the name, we write a pair of parentheses. For now, these parentheses are empty. Later in the lesson, we will learn how to place information inside of them. Next comes the colon. Just like the if statements and the loops, colon tells Python that the indented block of code follows. Finally, the indentation. The print statement is indented by 4 spaces. Everything indented under the function belongs to that function. Indentation is extremely important in Python. Without proper indentation, Python won't know which statements belong to which function. Now that we've created a function, does Python automatically run it? No. Defining a function simply tells Python that the function exists. To actually execute the inside the function, we must call it. We do that by writing the function's name followed by parentheses. As you can see in the line 5, I have not included the greet inside of the function, as if it was inside of the function, it will never get called. So make sure that you are not calling the function inside of the function that you just defined. So let's go ahead and see what the output comes out to be. And as you can see, hello, welcome to Python. The moment Python reaches greet, it jumps to the function and executes its code, then returns to continue with the rest of the program. One of the biggest advantages of functions is that they can be called as many times as we like. Now, if I wanted to print out hello, welcome to Python 3 times, instead of me writing 3 print statements that print hello, welcome to Python, print hello, welcome to Python, I just have to call the function 3 separate times. So I will write greet 2 more times. Now run this program, and as you can see, I've written 3 print statements just by calling the function 3 separate times. That's the power of reusable code. Just like variables, functions should have meaningful names. Good function names describe exactly what the function does. For example, calculate area should calculate the area, like display menu, check password, find average. These names clearly explain the purpose of the function. Avoid names like ABC, test, X. These names don't tell us anything about the function's purpose. As your programs become larger, meaningful names make your code much easier to understand and maintain. Python programmers also follow a common naming style called snake_case. In snake_case, functions are written in lowercase. Multiple words are separated by underscores. For example, take the example on the screen. The calculate area is all in lowercase, and as there are 2 words, they are separated by an underscore. Following this convention makes your code look clean and professional. Now let's create a few simple functions together. So first, let's create a function which calculates the area of the rectangle. As you can see, I've hard-coded the values of length and width into the function itself. At the moment, the values are fixed, but in the next section, we'll learn how to pass different values into a function so it can calculate the area of any rectangle. So let's go ahead and execute the code and see if it works. And as you can see, the rectangle's area has been calculated. So in the previous section, we learned how to create and call functions. Our functions looked rather simple. So whenever we used to call, let's say, a function, we used the function's name that we defined. Consider the calculating the area of the rectangle example. In that, we hard-coded the values of the length and the breadth. But what if we want to calculate area for a different rectangle? What if the user wanted to input the length and the breadth? That would quickly become impractical. Instead, we want one function that works for everyone. This is where parameters and arguments come in. They allow us to pass information into a function, making it flexible and reusable. Let's learn how they work. So these 2 terms are often confused, but they are actually very simple. A parameter is a variable listed inside the function's definition. An argument is the actual value that you send to the function when you call it. Think of it like ordering food at a restaurant. The menu says burger with filling, and the word filling is like a parameter. When you order, you choose chicken or veggies. Those choices are arguments. So let's see this in Python using the example example. Here I've used the parameter name. So let's call the function, and I will input in the name that I wanted to greet to, ABC, and it prints out hello ABC. Python takes the argument ABC and stores it inside the parameter name, after which we use that name and pass it into the function greet, after which the print statement prints it out. Functions can accept more than one parameter. Let's create a function that adds 2 numbers. As you can see, I've defined a function called add, in which the 2 parameters are a and b, inside of which there is a print statement which adds both of them and prints the result out. After that, you can see I've created 2 variables a and b, in which I allow the user to put in any integer that they like. After which I call the function and I use the variables created to pass them in. Now let's run the program and input some numbers. 10, enter 5, and the answer is 15. Similarly, let's improve upon the area of the rectangle calculation function. As you can see, I've created a function called calculate area, in which the parameters are a and b, and the print statement prints out the product of those 2. Sometimes we want a function to have a value even if the user does not provide one. For this, we use default parameters. Take the example on the screen. Now let's call the function without giving any argument. Now let's run the program, and as you can see, it still outputs hello guest instead, even though I did not provide any argument. Python will automatically use the default value that I've defined when I was defining the function. Now let's try to provide our own value. Now let's run the program, and as you can see, hello Alice gets printed out even if the default value was guessed. Since we supplied an argument, Python replaces the default value. Default parameters makes functions flexible and user-friendly. Until now, we've passed arguments based on their position, but Python also allows us to specify arguments by name. Consider the example on my screen. Even though we changed the order, the result is the same. Now, as you can see, even though I have changed the order of the arguments, Python will still print out the output. Now let's run the program. And as you can see, even though we clearly changed the order, the result is the same. That's because Python matches arguments using the parameter names. Keyword arguments improve readability, especially when a function has many parameters. Now, similar to our function of calculating the area for a rectangle, go ahead and try out to build a function that calculates the area of a circle. In the previous section, we learned how to make our functions more flexible using parameters and arguments. Our functions were rather simple, but what if we wanted to use that result later in our program? For example, store it inside a variable, multiply it by another number, compare it with another value, or save it in a list. Can we do that with the simple print statement that we used earlier? Not really. This is why Python provides the return statement. The return statement allows a function to send a value back to the place where it was called. Let us see why this is so important. Many beginners will confuse a print and return because both seem to show results. However, they serve completely different purposes. Take a look at the following example. Before running the code, think about what the output will be. Many beginners would expect that the output would be 30 and 30, but the actual output comes out to be 30 and none. Why? The function printed the value 30, but it never returned anything. Since the function didn't return a value, Python automatically returns a special value called none. None means no value. So while print displays something on the screen, it does not send back the value to the rest of the program. Now let's write the same function but by using the return statement. Now watch what happens. The output comes out to be 30. This time the value 30 is returned to the variable result. The function no longer prints anything by itself. Instead, it gives back the answer to the program. Think of it like a vending machine. You insert money, you choose a snack, the machine returns your snack. The function receives input, processes it, and returns an answer. One of the biggest advantages of return is that the return values can be used again and again. Take the following example. Let's run the program, and as you can notice something important, we calculated the square once. After that, we reused the return value multiple times. If we had used a print inside the function instead of return, this wouldn't be possible. Because the function returns a value, we can even use it inside larger calculations. Consider the following example. Let's understand what is happening. So first of all, the add 1020 returns 30. Then the Python should perform 30 into 5, which becomes 150. Now let's see this in action. And as you can see, the output is exactly 150. This is why return values are so powerful. They behave exactly like normal numbers, strings, or other data and can be reused into other bigger expressions. Functions don't just have to return numbers. They can also return strings. For example, here I've defined a function called full name in which the parameters are first and last. In the return statement, I return the first plus space plus the last. So which means when I give it the arguments Alice Johnson, it should return me Alice space Johnson. Now let's see it in action. And as you can see, it returned me Alice space Johnson. We can even use the return string elsewhere. Now let's run the program, and as you can see, instead of just getting the name, now I'm getting welcome Alice Johnson. Similarly, functions can also return true or false values. Python allows a function to return more than one value. Take the following example. Now let's run the program, and as you can see, the output is 15 and 5. Now let's understand this. The function returns two values, 15 and 5. Python automatically stores them inside two variables. This feature is extremely useful when one calculation provides several related results. In this case, which was the addition and the subtraction of two numbers. So far, we've learned how to define functions, pass information using parameters and arguments, return values from functions. Our functions are becoming more and more useful and reusable. However, there is an important question we haven't answered yet. Suppose we create a variable inside a function. Can we use the variable outside of the function? Or if we create a variable outside every function, can every function use it? The answer depends on something called scope. Understanding the scope is very important because it helps prevent bugs and keeps your programs organized. After learning about scope, we'll also take a look at Lambda functions, which are small, one-line functions often used for simple tasks. Let's begin. A variable's scope is the region of a program where that a variable can be accessed. In simple words, scope determines where a variable exists and where it can be used. Think of a classroom. Each student has their own notebook. Only that student can write in or read from their notebook. Similarly, a variable created inside a function only belongs to that that function. On the other hand, imagine a whiteboard at the front of the classroom. Everyone can see it. A variable created outside all functions is like that whiteboard. It can usually be accessed by multiple functions. There are only two types of scope we'll learn today: local scope and global scope. Let's begin with the local scope. A local variable is created inside a function. It only exists while that function is running. Consider this example. Here you can see the variable x works perfectly inside of this function. But what happens if we try to use it outside? I've altered the previous example by just a little bit. I've also called the print statement outside of the function. So let's see what happens if we try to use it outside of the scope. And as you can see, Python will produce an error, name error. Why? Because the x only exists inside of the function. Once the function finishes running, the local variable is no longer available. Think of local variables as temporary workers. They come into existence when the function starts and disappears when the function ends. Now let's take a look at the opposite. A global variable is created outside of all functions. Consider the following example. Now if I were to go ahead and run the program, the output comes out to be Python programming. Now notice something interesting. The function never created a variable named course. Instead, it used a global variable defined outside. Global variables can be usually accessed from anywhere in your program. As a beginner, you should try to use local variables whenever possible. Global variables should be only used when multiple parts of your program genuinely need to share the same information. So far, every function we have written, we have defined it by using def, the function name, and bracket, after which the code block. Now that is perfectly fine. However, sometimes we only need a tiny function that performs one simple operation. Python provides a shorter way to write such functions. These are called Lambda functions. A Lambda function is an anonymous one-line function. The basic syntax is as follows. Lambda parameters expression. Unlike normal functions, Lambda functions don't use def keyword. They usually consist of a single expression and automatically return the result of that said expression. They're most useful when you need a simple function only once. So let's write our first square function using Lambda. Let's run the program, and as you can see, we got the output to be 25. Notice how compact Lambda functions are. For very small tasks, they can make code shorter and cleaner. Let's review what we've learned today. Today you discovered what variable scope is, the difference between local and global variables, why local variables are temporary, how global variables can be shared across functions, what Lambda functions are, and how to create simple Lambda functions. You now understand how Python works, where variables can be used, and how to create concise one-line functions for simple tasks. Thank you for watching, and I'll see you in the next lesson.